So hi everyone, how are you guys doing? So first of all, let me welcome you back to the Unacademy, which is India's largest online learning platform for IIT JEE. And on this particular channel of YouTube, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students, and this is lecture number 11 of Ray Optics. And today we'll be talking about prisms, and this is part 2 of prisms. Okay, now before I get started with today's lecture, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching for the IIT JEE Mains and advanced examinations. So for 7 years, I had taught in offline setups, and offline I had been associated with some of the topmost institutes that you may have heard of. And now for past 1 year, I've been teaching online here on this particular channel on Unacademy. Now, as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I had to go through. So right now, when you guys take your JEE, that happens in two stages, right? So JEE Mains and JEE Advanced. So similarly, back when I took a JEE, it also used to happen in two stages. In the first stage, which was an objective paper, I secured an All India rank 182, and the second stage, which then was a subjective paper, I had secured an All India rank of 447. Now, as a student, I also qualified the NTSC Stage 2 examination, and I was in the top 1% in the NSCP paper as well. So, with all that experience, I finally decided to, coach and guide you students to your dream ranks and dream colleges and success through various examinations. So, in my past offline years of teaching, I have already coached many students to top ranks in the JEE, to their dream colleges, their dream ranks, and now I hope to continue doing that here online with you guys. So, hello Amod, hi AP, and hi Raj. How are you guys doing? Now, so students who are looking, about how to get the best of the education, in, even in this difficult time, and make sure that they are getting those dream ranks and getting to their dream colleges. So you guys can opt for the Unacademy subscription. This is a wonderful thing that will give you features like live classes where you get to interact with your educators on a regular basis. And you also have live polls and leaderboards in these classrooms, which keep these classrooms highly interactive and quite efficient. You also have regular test series and analysis sessions, which keep you on your toes and aware of your standing in the competition and lets you know where you need to focus more and where you might be lagging behind. And then, of course, you have live doubt clearing sessions. So that's one of the best features of all Unacademy Plus courses. I know doubts is something that all students are very worried all the time. They don't know what to do about the doubts, and when the doubts pile up, the pressure builds up. So with Unacademy Plus courses, every fourth session is supposed to be a live doubt clearing session. So after every three teaching sessions, you have one session dedicated entirely towards your doubt solving, where students may ask any of their doubts regarding the concepts that they have learned, regarding any difficulty that they're facing in problem solving. So with this feature, your doubts always getting cleared up. They never pile up, and you never feel that pressure. Okay. Now, along with all these benefits, of course, you are also getting the chance to study from the topmost educators from all across the country with this subscription from the comfort and safety of your home. So I think in this difficult time also, this subscription enables you to not only get a regular education but the best possible education that you can get. Okay, so how do you go about this? How do you make sure that you are getting the best possible education? So these there are simple steps of which of the first is to install the Unacademy app. Now, the moment you install the Unacademy app, you will realize you will unlock a lot of free features. So there are a lot of free courses running on the Unacademy app in which you can enroll simply after downloading the app. Then you have special classes, so you can take part in these special classes just after downloading and installing the app. And then you have quizzes like the one we just had. So all these free features you can simply unlock by installing the app, and you'll be asked an invite code. So all you need to do is enter this invite code RD Live, and that's it. You can unlock all these wonderful free features, and no subscription is needed. So your learning already starts the moment you download and install this app and use that code RD Live. Okay, now, once that will give you a flavor of how your preparation is going to go with your IITJ uh, with the Unacademy Plus. So once you get that idea, once you like it, and once you decide to take it to the next level, then you can go and opt for your Plus subscriptions. And for getting the Plus subscription, these are the steps that you need to follow. You can go to the Plus section of the app, select your goal as IITJ, and click on that Get Subscription button. Right, the moment you do that, you will be redirected towards the payment page where you will find a box that will be saying, do you have a code? So yes, you do. So this is the code that you might want to put. So RD Live. So if you put that, then you will get 10% flat off on all your subscription fees, whether you go for the Plus subscription or the Icon subscription. The fees of these two subscriptions are as mentioned below, and you will also realize when you click on proceed to pay, then you can also break these payments into smaller no-cost EMI options so that they reduce the burden of this payment. All right. So those students who don't know what the iconic subscription is, so let me quickly tell you about that. So this subscription is a relatively new offering by Unacademy, and this takes your JEE preparation to the next level by allotting you personal coaches. So those of you who know about Plus, in Plus you get access to all the courses on the Unacademy Plus. Now, but you don't have any personal coaches to mentor you and guide you very closely. So with the iconic subscription, you do that, you get that. So these personal coaches will mentor you throughout your IIT journey and guide you through all your thicks and thins. And along with these personal coaches, you also get the chance of attending a lot of IIT workshops, receiving expert guidelines from time to time, getting a study planner, and getting regular test analysis sessions. So with all these benefits, you will power through your IIT journey. All right. So those students who have just entered class 11th are worried about how to go about their studies for the next 2 years. No need to worry. Unacademy now presents a single one-stop solution for all your study needs. So you can opt for one of the 4 combo subscriptions now offered by Unacademy. So these combo subscriptions will take care of your class 11 CBSE studies, your class 12 CBSE studies, and hence your boards, your IIT preparations. So for your mains, for IIT preparation for your advanced, so everything that you might be bothered about taking care of by one of these combo subscriptions. The 4 combo subscriptions that you can opt from are as follows. The first combo offers you the iconic subscription for IIT and plus subscription for class 11th and 12th, and this combo starts at roughly 4,600 a month. Then you can choose a combo which offers you the plus iconic subscription for all these 3, and this combo starts at around 5,500 a month. Then you can choose a combo that offers you plus for IIT and plus for 11th and 12th, and this combo starts at roughly around 3,000. And finally, you have a combo which offers you the plus subscription for IIT and iconic for 11th and 12th, and this combo starts at 3,900 a month. Depending on your study needs, you may decide where you need to focus more, and accordingly, you may choose a suitable combo subscription for yourself. And once you do that, you can leave all your study worries behind. Next, students who are following us on the JEE English channel of YouTube can also connect with us on the Telegram app using this link. That will make sure that you're not missing out on any of the lectures and sessions happening on this amazing channel. So there is free content being provided to you by Unacademy through this channel, so that we want to make sure that students who can't afford these subscriptions also should be getting access to quality education. So make sure that you are connected with us on the Telegram app so that you're not missing out on any of the amazing contents available here absolutely free of cost. All right, with that, let's get started with today's discussion. So as I said, this is lecture number 1 or 11 of ray optics, and today we'll be talking about prisms, and this is part 2 of prisms. So in the last class, we talked about prisms and we discussed about deviations produced by prisms, how is the minimum deviation produced, and so forth. Today we'll be focusing more on thin prisms. Okay, so today the focus area is going to be more on thin prisms. All right, so why don't we get started? So before we start today's discussion, as I usually like to do, let's solve some problems from our discussion from the last class. So I usually like doing that so that I am sure that you guys have been watching the lectures regularly and following them. Okay, so here is the first question for today. So a ray of light makes an angle of 60 degrees with one of the faces of the prism and suffers a total deviation of 30 degrees on emergence from the other face. Now, if the angle of the prism is 30 degrees, show that the emergent ray is perpendicular to the other face. Okay. Also calculate the refractive index of the material. Okay. Let's see if you can figure this out. All right. So try this. So good evening, Mahi. How are you? Okay. Hmm. So let's see. So guys, try this quickly and let's see how many of you have been following the lectures and how many of you remember things discussed in the last lecture. Okay. So hurry up, hurry up. I hope you remember the angle of deviation formula that we had discussed, right? So just try and remember that, and you should be able to figure this out. Okay, this is a simple enough question. Most questions on ray optics are not very complicated. They appear very tricky, but if you have been following everything, if you follow all the discussions, if you remember everything, all the formula, then trust me, these questions are pretty basic and very simple, straightforward formula application. That's about it. That makes ray optics a highly scoring area, by the way. Okay, for anybody trying this. Okay, so let me maybe wait for one more minute. Okay, so I'll give you one more minute to try this and give me your answers. Okay, let's see how many of you figure this out. Hmm. Okay, so anyone having the answers? Okay, no one. That is strange. Okay, still some time left. Hmm. Well, let's see. All right, never mind, never mind. So let's just go ahead and solve this. So let's see what all is the information that you've been given. You've been given that the light, incident light makes an angle of 60 degrees, and you've been told that the total deviation is 30, and the angle of prism is also 30. All right, so let's see if you remember. Now, if you will try and remember your delta, the angle of deviation was given as I plus E minus A. Okay, now you've been told I equals 60 degrees, A equals 30 degrees, and delta equals 30 degrees. Okay, so all this is given to you. Okay, so refractive index is root 3. Okay, okay, let's see if that is correct. All right, so these things are given to us. So let's just substitute all these values. So I realize 30 should be equal to 60 plus E minus 30. So that gives me E as 0. Yes, the angle of emergence is 0. So that is what we had to prove. We had to prove that emergent ray is perpendicular to the other face. So yes, since E is 0, emergent ray comes out along the normal. Okay, so that is the proof that yes, that the emergent ray is perpendicular to the second surface. Now, once you know E is 0, now I can say since E is 0, R2, you remember, would also be 0. Okay, if the emergent ray is coming out normally, if the angle of emergence is 0, so second angle of incidence R2 would also be 0, right? I hope you remember sine R2, mu sine R2 was equal to sine E. Okay, so therefore, and also since A was equal to R1 plus R2, that gives me R2 equals 30 degrees. Okay, R1 equals 30 degrees. So now that I know R1 and I know I, and finally, you know that sine I equals mu sine R1. What will that give me? Sine of 60, which is root 3 by 2, equals mu into sine of 30, which is 1 by 2, giving you mu as root 3. Absolutely correct, guys. So yes, the refractive index of the material is root 3. That is the right answer. Okay, so well done, well done. Great, great, great. So let's try another question then. Okay, let us try another question. This says the refracting angle of a prism is 60 degrees and the refractive index of the material is root 3. Calculate the minimum deviation. So what will be the minimum deviation? So this should be simple again. Okay. Now, if you remember how to relate the refractive index with the angle of minimum deviation, you should be fine. Okay. So let's see. Try this. Let's see how much of you remember from our previous discussion. That is why these questions are important. I want to check how much or how regularly you guys have been following and how much attention you've been paying when you attend the lectures. Okay, so 60 degrees. Okay. So yes, that might be the correct answer. So if you remember for delta min, you will remember I is equal to E. So therefore, delta min was 2I minus A. So that makes your I equals delta min plus A by 2, correct? And also R1 equals R2 equals A by 2. So if you remember from Snell's law, we had said that mu would be sine of delta min plus A over 2 over sine of A by 2. This was the relation that we had found, correct? So from here, what I realize is sine of delta min plus A by 2 equals mu sine of A by 2. Now, A I've been told is 60. So since A equals 60, what I realize is sine of delta min plus A over 2 equals root 3 to sine of 30. Okay, so which is right root of 3 by 2. Therefore, what I can say is delta min plus A by 2 equals 60 degrees. And from here, I can get that delta min to be equal to 120 minus 60, which is in fact 60 degrees. Okay, so yes, 60 degrees is the correct answer for your minimum delta. Well done, very nicely done, people. So yes, you have been following the lectures. Very good, very good. Good to see. All right, so let's try one more question. I think yes, one last question from the discussion that we had a day before. Okay, so this says find the minimum and the maximum angles of deviation for a prism for which the angle is 60 and the mu is 1.5. See if you can figure this out. Hmm. What would be the minimum angle of deviation and the maximum angle? Okay. So for minimum angle, I hope you remember the condition, and for maximum angle, again, the condition would be that either I or E would be 90. Okay. Hmm. So try this, and then let's see. So well done so far, by the way. Very nicely done. You are have been giving the correct answers. Very impressive. All right, now let's see you try this one. Hmm. Okay, so this might be a little difficult for you to write. The angles will not be exact. Okay, so I think I'll only solve this. Okay, let's see how you would have gone about this one. So you've been told to find the minimum angle of deviation. So I can say for delta equals minimum, I know the condition I equals E. And I know and mu is equal to sine of delta min plus A by 2 over sine of A by 2. Again, this is one of the most important equations for prisms. So do remember this one because a lot of questions from prisms are asked from this equation. So now what I can say from here is that sine of delta min plus A over 2 would be equal to mu, which is 1.5 into sine of A by 2, and A was 60. So sine of A by 2 would be sine of 30, so into 1 by 2. So then I can say delta min plus A by 2 would be equal to sine inverse of 3 by 4. Okay. And from here I can get delta min. Delta min would be 2 sine inverse 3 by 4 minus 8, 60 degrees. That would have been your answer. Okay. So unless you're given the value of sine inverse 3 by 4, I don't think you can calculate this, the exact angle without a calculator. So why don't we use a calculator and tell you the answer? So sine inverse. Okay, so my my unfortunately enough, my calculator does not have sine inverse function. Maybe we can Google this. Inverse of 0.75. Okay, so sine inverse of 0.75 is roughly 48. Okay, so roughly 49 degrees. This is roughly 49 degrees. So this is roughly 49 degrees. Even if I put it, okay, so delta min from here would be equal to 98 minus close to 88 minus 60. So roughly around 38. Okay, so that is how I would have found my delta min. Okay, now how about delta max? So let's add another page here and calculate the value of delta max. Okay, now I can say for delta max, I can say I would be equal to 90. Okay, so I is 90. And how about R1? Therefore, I can say is E by 2 sine of R1 would be equal to 1. So sine of R1, or R1 rather, we can say R1 would be sine inverse of 2 by 3. Okay, so which will tell you about R2. R2 would be 60 minus sine inverse of 2 by 3. Okay, so once you have R2, you can find E. Okay, so again. E would have been sine of would have been 1.5 times sine of R2. So from here, I would have found E, and delta max would have been 90 plus E plus 60. E plus 30 would have been my answer. Okay, I would have found the value of E from the above equations, and my final answer would have been E plus 3. Okay, I hope that is clear to all. Okay. All right. So finally, let's move on to our discussion of thin prisms. All right. So next, I wanted to talk to you about deviation produced by a thin prism. So thin prism is one. Prism is one where A tends to 0. The angle of prism tends to 0. Okay. Now you will realize what is that if since R1 plus R2 equals A, so therefore I can say R1 tends to 0 and R2 also tends to 0, correct? Because A is tending to 0. So for such a prism, R1 and R2 also tend to 0, and since R1 and R2 tend to 0, and since I know sine I equals mu sine R1 and sine E equals mu sine R2, and since these two angles are tending to 0, so I can say for such a prism, I also tends to 0 and E also tends to 0. So for thin prisms, I can assume that all the angles related to the prism always tend to 0. Okay. Now, if I wanted to find the deviation produced by a thin prism, then the deviation delta I know is simply I plus minus A. Okay. And for delta min, now what I can also say is that since all the deltas are very small, so I can say that this delta would be roughly equal to delta min. Okay, there is only a single deviation almost produced by a prism because the angles are tending to 0 as I is approximately equal to E. Right, because both are tending to 0. Since both are tending to 0, so I can assume that I tends to E. I is almost equal to E. So delta can be assumed to be equal to delta min. So what I can say is therefore mu equals sine of delta plus A by 2 over sine of A by 2. And again, so let me write that also since all angles tend to 0. So what I can say is delta plus A by 2 also tends to 0. So now I can apply approximation, small angle approximation, and I can write this as delta plus A over A. So the delta produced by a thin prism can be written as A times mu minus 1. So that is a very important formula related to thin prisms. So thin prisms produce a deviation which can be given as A times mu minus 1. So the deviation produced by a thin prism depends on the angle of the prism and the refractive index. Okay, so very important formula. So remember this, very, very important. Must remember this formula. This is the deviation produced by a thin prism. Okay, it is A times mu minus 1. All right. So again. So I can write, therefore, such a prism almost produces a single deviation for the emergent light, which can be considered as delta min. This can be considered as delta min also, delta max also you could have taken it. Okay, so hi Purna Prabhas. Hello Prabhas, how are you? All right. So this deviation depends on the angle of prism. Okay, the angle of prism. Second, the refractive index of the prism. Again, please remember here the approximation was that all the angles will have to tend to 0. Okay. So how are you, Prabhas? And finally, this is our equation, delta equals A times mu minus 1. Very, very important. Okay, so remember this. I can highlight this. Again, if you remember this, then all your problems of thin prisms are sorted. All your problems of thin prism will use this formula only. Okay. Again, I hope everything is clear. So the approximations are all angles are tending to 0. Your delta tends to 0, your A tends to 0, your I tends to 0, your E tends to 0, your R1, R2, everything is tending to 0. Okay. Right. Okay, so why don't we start with a question here? So with that knowledge, let's try a question. This question tells you a prism having a refracting angle of 4 degrees and a refractive index of 1.5 is located in front of a vertical plane mirror as shown. A horizontal light ray is incident on the prism. What is the angle of incidence at the mirror? Okay, so the angle of incidence on the mirror. Okay, this should be simple. So you realize if this is the delta, this will also be delta, correct? So the angle of incidence is equal to delta, in fact. So that should help you with the answer. Okay, I've given you the hint now. Okay. Again, you realize the angle is 4. So usually for thin prisms, usually we consider the angle of prism to be in anywhere less than 10 degrees. Okay, for applying small angle approximations, your theta should be tending to 0 in radians. Okay, and in radians, if the angle tends to 0, so pi radians is equal to 180 degrees. So in 180 degrees, any angle which is less than 10 can be roughly approximated as a small angle. Okay. So you will realize for a 10-degree angle, the angle in radians would become almost 1 by 6. Yeah. So any angle, in fact, less than 5 degrees is definitely a small angle. Okay, so AP says 2. All right. So yes, I had shown you that this is the actual path of the light that it would have gone in, and okay, this was the original path, and this was the final path. So the delta would have been this angle, and if this angle was delta, this angle of incidence would also have been delta. and you know that the angle of prism is 4 and the refractive index is 1.5. We just said that delta is nothing but a times mu minus 1, so that will be 4 times 1.5 minus 1, which is in fact 2 degrees. So that is the correct answer. Yes, well done, AP and Raj. You realize the questions from thin prisms are super simple. You don't have to worry. Next, we will talk about a dispersion of light. Of course, this is a very important phenomena, and so you know that all prisms cause the dispersion of light, right? This is it. This is a prism creating a dispersion of light. So what is dispersion? Dispersion of light is any light, white light, when incident on any surface, being broken into its constituent colors. That is called dispersion. When the constituent colors start moving separately of the white light. Okay, here also you can see this is also dispersion of white light. So these are the examples of dispersion. All right, so let's get back to analysis of dispersion produced by thin prism. So dispersion of light refers to breaking off a white light into its constituent colors. Correct. So that is what we call dispersion of light. All right. Now, why is that dispersion happening? That dispersion is happening because you will realize that there is an equation called Cauchy's equation. Okay. The refractive index, the refractive index for different colors of light is different. And given by Cauchy's equation. So this is a very important equation. This equation tells you that mu is A plus B over lambda square. Okay. There are other terms also to Cauchy's equation. C over lambda to the power 4 and so on. D over lambda to the power 6. But because lambda is usually uh, we usually ignore all these terms. These terms are usually ignored. These terms are ignored. And final form of Cauchy's equation is actually written like this only. A plus B over lambda square. Okay, hi, nothing peace. How are you? Okay, so this is the form of Cauchy's equation that you mostly know as. Okay, the true Cauchy's equation is a very long polynomial in terms of lambda. Lambda being the wavelength of light, by the way. Okay. So we will stick to this equation. In fact, let's even get rid of these terms before you get confused. This is the only extent of the equation that we are interested in. So from here, what you realize is that the greater the lambda, the lower is the mu. Okay, lambda is equal to the wavelength of light. Sorry. And A and B are constants depending on the nature of the refracting medium. Depending on the refracting medium. So, for instance, if you had a glass, then you have different kinds of glasses also, flint glass, crown glass. So for different glasses, A and B would have had different values. Okay, but for one kind of a substance, A and B are fixed, they are constants. Okay, and so you realize for one substance, the more the lambda, the smaller is the mu. Now, more lambda means more lesser frequency. So which one of the following has the least frequency? So this one. This has the lambda which is greatest. This has the lambda which is smallest. So what you realize is mu of violet is the largest, is highest across the constituent colors, and mu for red is the lowest for all the constituent colors. So nothing. Piece is saying, sir, sometimes from fluid mechanics we get direct formula based questions. Yes, in mains you will. In mains you will mostly. Okay, I am also great here. But this is the easiest part of your examination. Okay, ray optics I think is the one of the most scoring topics. Okay, at least in mains. In advance maybe they can get some tricky questions. They can get creative about problems. But in mains, the ray optics problems are very straightforward, very simple formula based. If you know all your formula, if you have practiced it a bit, then you should not be bothered about the problems from ray optics. So what we realize is that Cauchy's equation is suggesting to us that the wavelength, because the wavelength of different colors is different, so the mu corresponding to every color is different. Okay. Now, what you realized previously was that the deviation produced was dependent on mu. Okay. So greater the mu, greater would be the deviation for a light. So what you realize is that when you have a white light incident, then because the mu for R is the lowest, so R suffers the least amount of deviation. Okay, the red color suffers the least amount of deviation, the violet suffers the most amount of deviation, and the average deviation is suffered by yellow light. Okay, so that is what causes dispersion of light. Different colors come out with different angles of deviation, and hence they are not parallel anymore, and that is what causes the colors to split apart. Okay, so that is the entire idea behind dispersion of light. Okay, so the entire reason for dispersion is this Cauchy's equation. Okay, now there are some terms that you can define. Okay, so let's just write that also as the refractive index corresponding to red color will always be the least for any material. Red light is least for a certain refracting material. And highest for violet color. Therefore, these colors suffer different deviations and hence dispersion happens. Okay, so that is the entire logic behind dispersion. Okay, so sir, I'm not getting much ideas to do rotational dynamics. Okay, so in rotational dynamics, if you ask me, Rishul Arora says, sir, physics के question हो जाते हैं पर time बहुत लगता है. Please tell how to increase speed. So देखो भाई, speed जो है वो that is only a matter of practice और कुछ भी नहीं है. If you have solved a variety of problems and if you keep on solving more problems, तो फिर अपने आप ही आपको जल्दी जल्दी क्लिक करने लगेगा ना. सो एक एक टाइप की प्रॉब्लम अगर मैं दूं वैसे आप चार प्रॉब्लम्स कर चुके हो तो आपको इमिजिएटली पता है. ठीक है, रिफ्लेक्स एक्शन बन जाएगा. सो बाकी एक कैलकुलेशन पार्ट होता है. देखो प्रॉब्लम सॉल्विंग में क्या है, दो पार्ट्स हैं. एक है थॉट, कैसे सॉल्व होगा, थॉट और अप्रोच. अप्रोच क्लिक करने में टाइम लग रहा है या फिर सॉल्विंग, एक्चुअल सॉल्विंग। तो दो पार्ट्स हैं, ठीक है। सो यू नीड टू डिसाइड कहाँ आपको ज्यादा टाइम लग रहा है यार इशुल, ठीक है। अगर थॉट में ज्यादा टाइम लग रहा है, अप्रोच में ज्यादा टाइम लग रहा है, तो फिर तो आपको थोड़ी सी ज्यादा प्रैक्टिस की जरूरत है। अगर सॉल्विंग में ज्यादा टाइम लग रहा है तो फिर सॉल्विंग के बेटर मेथड्स ढूंढो, ठीक है। देयर आर लॉट ऑफ शॉर्टकट्स, लॉट ऑफ डिफरेंट डिफरेंट टेक्निक्स, एक ही प्रॉब्लम को बहुत तरीके से सॉल्व किया जा सकता है। तो अगर सॉल्विंग में ज़्यादा टाइम लग रहा है तो थोड़ी सी प्रैक्टिस करो सॉल्विंग की, और फिर थोड़े ऑल्टरनेट मेथड्स ढूंढो, थोड़े से शॉर्टकट्स ढूंढो, ओके। तो नथिंग पीस, सो आई कांट अंडरस्टैंड, आई एम नॉट गेटिंग मच आइडियाज टू डू रोटेशनल डायनेमिक्स। सो रोटेशनल डायनेमिक्स में क्या करना चाहते हो? एज फार एज मेंस इज कंसर्न, आई टेल यू, मेंस में जो मेनली क्वेश्चन आता है, एक तो मोमेंट ऑफ इनर्शिया का जरूर आता है। दैट हैज बीन द ट्रेंड एटलीस्ट। मोमेंट ऑफ इनर्शिया कैलकुलेशन का यूजली एक क्वेश्चन आता ही आता है, सो एटलीस्ट फोकस ऑन दैट, ठीक है ना भाई। Make sure your moment of inertia calculation part is pretty sorted, okay। usually रोटेशन से एक प्रॉब्लम इसका आएगा ही आएगा, ठीक है। सेकंड, आपका प्योर रोलिंग वाला जो पार्ट है वो आप अपना सॉर्ट करके रखो। अगेन, if you have seen my lectures, I have discussed things in great details। तो अगर आपको कोई कॉन्सेप्चुअल प्रॉब्लम है तो आप लेक्चर्स देख लो, और बाकी थोड़ा सा इन दो पार्ट्स पे स्पेशल फोकस करके प्रैक्टिस करो तो हो जाना चाहिए। वो क्लास ऑन शॉर्टकट ट्रिक्स यूज्ड बाय यू, ओके। सो यार वो, there's a reason why I don't want to do that class. Why is, okay, I can tell you certain shortcuts, but then most of the shortcuts come to you as you solve more and more problems. I'll tell you. So when I was a student, I had so we used to have this different a different pattern altogether, right, for JEE. So what we had was we used to have a screening paper. So screening, which was an objective paper. Now that paper was usually held in November. Okay, November, the screening paper was held. The result would be declared somewhere in Jan first week, I think, if I remember it correctly. Okay, now if you qualify this, then you take the second stage, which was then called mains, which was a subjective paper. Okay, and this paper used to happen in May. So what you would realize is that there was a 6 month gap, 6 month gap between these two papers. So what happened was that when I, as a student, was preparing, so I finished all my syllabus here only. I finished all my syllabus here by November, right? So for this 6 months, I did not know what to do. I had solved my entire HCV, I had solved the entire Erudov by November. I had solved all HCV plus Erudov plus sheets given by my teacher, all of them by November. So then I did not know what to do for the next 6 months. So then I would practice more and more, and then I would sometimes I would solve problems again, but I decided that I'll use a different approach now. Okay, so when you do that, when you consciously spend time on that, okay, trying to find more efficient methods, okay, then you stumble upon a lot of shortcuts that you can use, okay. My teachers never said any shortcut. They will say no shortcuts will be in physics. No, no, no. There are a lot of shortcuts. There are a lot of shortcuts. Okay, don't worry. There are. There are. At least for mains part, definitely there are. Definitely there are. So there is a one session that I had taken, how to get answers from options. Answers from options. So do watch that. That will help you. In mains, at least I will tell you per subject, at least in physics, you can get up to 3 to 5 answers directly from options. That is my guarantee. Out of the 30 questions. Okay, so 30 questions in physics, right? Out of 30, if you can get 3 to 5 questions answered right from options, then that saves you a lot of time, right? So you can watch that lecture. And second thing I want to tell you is that before you take to any shortcut, you should always have your fundamental methods of solving the problem clear, because and that is when you will realize, see, there will be a lot of shortcuts, a lot of tricks, but every shortcut, every trick has its limitation. It is an approximation usually for a certain kind of a problem, right? For a certain kind of problem, it may not be applicable in every situation blindly. So until unless you understand the logic of the shortcut very well, you should not be using the shortcuts, because then what happens is that you may end up applying the shortcut in the wrong situation, get the wrong answer, and then blame me. The sir told the shortcut, I used the shortcut, and I got the wrong answer. So that is the reason there is a risk involved. If you do not apply the shortcut in the right situation, you won't get the correct answer. So that is why I don't want to introduce something which has some risk right now. Okay. I'll tell you the general shortcuts that you can go for. Okay, so there is one of my favorite shortcuts. Okay. So in rotation only. I think if you watch my lectures, you would have seen this. So there is this typical problem. Okay. So I think I keep mentioning these shortcuts in my lectures also. So if you have watched my lectures, you would have come across these. So this is a typical problem where this has a mass m, radius r, this has mass m1, this has mass m2, and you're supposed to find the two accelerations, right? You're supposed to find the acceleration of these masses. You are asked what is a? What is the value of a? Hmm. So this is one of my favorite shortcuts for solving this particular problem. Okay. So the idea is that you make the length 0, the length of the string 0. Okay. So simply remove this. Instead of writing different equations, simply remove this. Turn your objects into point objects. Attach them here and here, and just take torques. Take torques about the center C. When you take torques about the center C, what you will realize is that m1 minus m2 gr would be the net torque, and that would be equal to the I, which would be mr square by 2 plus m1 r square plus m2 r square times alpha. Okay, and you know alpha r equals a. So this is one of my favorite shortcuts. But again, right? So this will give you a one-line answer, right? You can see a lot of problems in your HCV can be solved using this. So HCV has this problem, right? Where the pulley is also rotating, it has some moment of inertia. So this is the shortcut that gives you a one-line answer. Okay, just this one line, and you have your answer of A. Correct? Instead of writing 6 equations. Otherwise, you would have had to write one equation for this, one equation for this, one equation for rotation of this, and one equation relating the alpha and the A. So 4 equations. So instead of 4 equations, you have one equation. Okay, so that's one shortcut. But then you will realize that if you have such a question where you have two pulleys, okay, so there was another question of two pulleys. Here also you can apply this, by the way. So M, as long as the pulleys have the same radii, you can apply this. Okay. I think this was also a question in HCV. Okay, you have a situation like this, and now you're supposed to find the acceleration. So you mount all the objects together. Okay, so you have one pulley, over that you have the second pulley. Okay, and then you attach both these masses here, and then instead of here you will just multiply this by 2, the net moment of inertia. Okay, so it works here also, but the problem is, see, why is it working? Because all these materials have the same alpha. Okay, this has the same alpha. Okay, the alpha here and the alpha here. As long as the radii are same, the alphas are same. And even if this was a point mass attached here, this would have also moved with the same alpha. If this was a point mass attached here, this would have also moved with the same alpha. Okay, but that won't be the case if the radii of the two pulleys are different. Okay, so this trick works as long as you have multiple pulleys also attached to multiple masses. with the same radii, so that every pulley has the same alpha, and every point mass, if you attach it to the pulley, should have the same alpha. So as long as things have same alpha, then you can apply this equation. Single equation of torque relating alpha. What to solve HCV subjective type? Why not? Why not? HCV subjective type तो करना ही चाहिए यार, वो कर लोगे और थोड़ा सा स्पीड से करो आप उसे, ठीक है, तो आपको मेंस का कोई क्वेश्चन डिफिकल्ट नहीं लगेगा. So again, so these are the kind of shortcuts that I can tell you, but then not at the last moment. I don't recommend the shortcuts at the last moment, because you haven't had time to practice enough with these shortcuts. You don't know in what situations, what all situations you can apply these shortcuts. So whenever I'm telling you a shortcut, it's not only for one situation, okay? It's not only one question can be solved. There should be at least, 5, 10 types of problems that you should be able to solve with this shortcut, right? So unless it is that shortcut is not very useful, no? If I have a shortcut for one kind of problem, then there are infinite kinds of problems. How many shortcuts will you learn? Okay. Plus, I want students to learn about these shortcuts when they're preparing in their 11th and 12th only. So when you would be studying rotation, then you should have tried this shortcut and tried it in a lot of problems, realized where it works, where it doesn't work well, and where you can find other methods also. So until unless you have done your own practice with a shortcut and your own research, I usually do not advise shortcuts, because at the end moment they may just confuse you. You may not even remember the shortcut properly, and you may try and use it. If you use it wrongly, then you of course land in trouble. If you don't remember it correctly, again also you land in trouble. So all right, nothing peace. So that is my take on shortcuts at the last moment. Okay. All right. So here we said this. Now we will talk about two important terms related to the deviations. So one, we talk about the there are three important terms. One, we talk about angle of dispersion. Angle of dispersion. So you realize the angle of dispersion is actually defined as the angle between the red ray and the violet ray. Okay, that is what we call the angle of dispersion. So if I could extend this, and if I could extend this, then this angle is called the angle of dispersion. Okay, omega, or let's call it theta. Okay. So how do you calculate this angle? Originally all the light rays were traveling in one path. Now the red ray got turned by delta R and the violet ray got turned by delta V. So can I say that theta would be equal to angle of dispersion is the angle between the red light and the violet light. Okay, that is the angle in which all the colors are spreading. Okay, so that is why that is called the angle of dispersion. Okay, so can I say theta would be nothing but delta V minus delta R. Okay. Now, if for thin prisms, then I can say that this theta would be equal to A times mu of violet minus mu of R. Okay. So you should know this formula. Again, usually whenever dispersion questions are asked, they are usually asked from thin prisms only. Okay, because in thin prisms, the angles of deviations are very easy to calculate. Okay. Okay, so this is the first term that I wanted to tell you about. Second term, you have average deviation. Average deviation. So average deviation is either the average of the deviation suffered by the red light and the violet light. Also turns out it is also the deviation suffered by yellow light. Turns out whenever you have dispersion of light, then the average deviation is suffered by the yellow light. So deviation suffered by yellow light. That is called average deviation. Also equal to delta violet plus delta R by 2. So it is, you can have two ways of defining this. The average deviation is also defined as the average of the deviation suffered by the two extremes, which is almost roughly considered equal to the deviation suffered by the yellow light. So obviously for thin prisms, again, for thin prisms, this becomes equal to delta average becomes equal to a times mu of y minus 1, or also equal to a times mu of violet plus mu of red by 2. Okay. Now you will also know one thing, whenever the refractive index is mentioned to you. So when I say the refractive index of glass is 1.5, the refractive index of water is 4 by 3. So which refractive index am I talking about? We usually refer to the refractive index corresponding to the yellow color. Okay, please remember this. So that's an important note that you must know. Generally, the refractive indices are mentioned with respect to yellow light. As I said, the refractive index for different colors is different, right? So what do I mean when I say the refractive index of glass is 1.5? For which color is it 1.5? Because for different colors it will be different. Similarly, when I say the refractive index of water is 4 by 3, so for which color is it 4 by 3? For different colors, again, it will be different. So whenever we are mentioning the refractive index in general, we are referring to the average refractive index or the refractive index corresponding to yellow color. Please remember that. Okay. So the next term that I wanted to mention to you is called the dispersive power. Again, a very important term. The third term related to dispersion by thin prism is dispersive power. So it is defined as the ratio of the angle of dispersion to the average deviation. So very important term again. So dispersive power, which is usually put by angle omega, is theta over delta yellow. Okay, so remember theta was uh, nu of violet minus nu of r into a, and average deviation was a into nu of y minus a. So this essentially becomes nu of violet minus nu of red over nu of yellow minus 1. Okay, so for any prism, this is how you measure the dispersive power. Okay, so pay attention to this. This is a very important term related to dispersion. Okay. All right. Now I hope if all the terms are clear, then should we move ahead? Let's go ahead and practice some problems then. All right. So here is a question on prisms. From what we have studied so far, so refractive index of glass for a red and violet are given to you as 1.5 and 1.6 respectively. Okay, so these are not the accurate values. Okay, these are just imaginary values, because 1.5 is actually the refractive index for yellow. Okay, so find the refractive index for yellow approximately and the dispersive power of the medium. Okay, so it should be simple. I told you the refractive index of yellow would be roughly, approximately, I can tell you what the refractive index of yellow is. Okay, I hope you remember that from this. The average deviation. Okay, so from the average deviation, you compare these two equations. So refractive index for yellow is roughly the average of the refractive indices for violet and red. Okay, so hurry up, give me your answers now. And once you know that, then dispersive power also, if you remember the definition, pretty straightforward. So what will be the refractive index of yellow color? So try and answer. Simple, very, very simple. Once you know that, then dispersive power of the medium is, we just discussed it. Okay. Okay, so 1.55. Yes, that is the correct answer. So of course, we just discussed it. We just discussed that mu of yellow is equal to mu of red plus mu of violet by 2. Khatam. Plus ye karna tha. 0.5 plus 0.6 by 2. So that is approximately 1.55. Approximately. Exactly. So once I know this, I know dispersive power omega is mu of violet minus mu of red over mu of yellow minus 1. So this also can be calculated easily. It would have been 0.1 over 0.55. That would have been your correct answer. 1 over 5.5. That is the dispersive power. Okay. Okay. All right. Let's move on to the next question. Try one more. Let's see. Let's see how much you guys have been following. So this says that the refractive indexes of a flint glass for red and a violet light are 1.613 and 1.632 respectively. The angular dispersion produced by a thin prism of the flint glass having refractive angle as 5 degrees is. What is the angular dispersion produced by a thin prism of angle of refraction 5? Angle of prism as 5. Okay. Again, this should be super easy. We just discussed the angle of prism. In case you don't remember, the angle of dispersion was A times mu of violet minus mu of R. So कुछ भी नहीं करना है, सीधा फॉर्मूला लगाओ. It'll be roughly around 1 degree. Okay. Let's see. I hope you just watch it. You should know the angle of dispersion theta was A times of violet minus of R. Very straightforward formula-based questions on thin prisms. So thin prisms is in fact the easiest topic of ray optics. That is why I left it for the last. Okay. There is absolutely nothing that you need to worry about here. Then this was 1.632 minus 1.61. That would have been 5 into 0.019. So pretty straightforward from here, I think. 5, 0. This would have been the angle of dispersion. Okay. Roughly 0.1 degrees. That would have been your dispersion. Again, straight formula based question. Okay. All right, moving on. Now, this is another kind of situation that you are asked usually. You are asked that you have to combine two prisms, okay, and you have to find the angle of such that there should be dispersion without average deviation. Okay. So what you do is you combine two prisms upside down. So one guy is producing positive deviation, another guy is producing negative deviation. So if the aim is to produce dispersion without average deviation, what does that mean? That the deviation produced for yellow should be zero. Okay, because that is the deviation, average deviation. Okay, so you want your light to actually, the yellow light to become parallel to the incident light. If that happens, then you say average deviation is zero. What will be the condition for that? So let's assume that here, if this guy has an angle of A and this guy has an angle of A dash and this guy has a refractive index of mu and this guy has a refractive index of mu dash. Okay, so what can I say for yellow? Okay, so for prism one deviation produced for yellow light would be equal to delta 1 is plus a mu of y minus 1. Okay. Similarly, for prism 2, the deviation produced for yellow light that will be equal to, again, applying the same formula. However, since this guy is inverted, so the deviation produced by the second prism would be negative. All right, minus of a dash times mu y dash minus 1. Now, for no average deviation, I can say for no average deviation, what you realize is that the sum of delta 1 plus delta 2 should be equal to 0. Okay, so what will that give me? That a into mu y minus 1 should be equal to a dash into mu y dash minus 1. Okay, so from here, if you knew the refractive indices, so this has 4 variables. If you know any 3, then you can find out the 4th one. Usually what they ask is, okay, they will tell you the a, they will tell you the mu, and they ask you the a dash. Okay, so one angle is usually given, the two refractive indices are usually given, and the other angle is usually asked. So that is what is asked. So this will be the case in which there would be dispersion but no average deviation. Okay, so you will realize the light rays would actually travel like this. Light rays traveling like this, but the yellow would have been traveling parallel to the original path. Okay, so there would be dispersion, and the angle of dispersion will not be zero. However, there would be no deviation as the yellow light would emerge parallel to the incident light. The average deviation is zero. When I say without deviation, dispersion without deviation, we mean average deviation. Next, you have a condition where you are asked average deviation without dispersion. So from prism 1, the dispersion used is, so angle of dispersion by prism 1, that'll be equal to theta 1 equals a times mu y minus mu red. Similarly, angle of dispersion produced by prism 2, how much will that be? Theta 2 would be equal to minus a dash this minus this. Now, for no deep dispersion, you want the total angle of dispersion to be zero. What does that mean? That means it is the light is spreading here. The light had started spreading here, and the light starts to diverge at prism 1, starts to converge at prism 2. So, if you have light rays finally moving parallel like this, okay, which may not be parallel to this incident light, so that is called deviation without dispersion. Okay, so the condition for that would be for deviation without dispersion, you want the net angle of dispersion as 0. So the condition would be that A times mu of violet minus mu of R should be equal to A dash times mu dash violet minus mu dash R. If that condition is satisfied, then you will have a deviation without dispersion. These are the conditions for different cases. Again, very simple. All you need to know is if deviation is 0, then the average deviation has to be 0. So deviation of yellow light produced by one prism should be equal to the deviation of the yellow light produced by the other prism, and it will be negative because they have been put upside down. Okay. Similarly, if you want to achieve deviation without dispersion, then the angular dispersion produced by one prism should be equal to the negative angular dispersion produced by the other prism, so that the net angle of dispersion is 0. Okay. So as simple as that. Now let's just try two questions with that, and that is it. That is where we can wrap up today's discussion then. Okay. So here is your question. You have been asked find the angle of flint glass prism which should be combined with crown glass prism of angle 5 degrees so as to give dispersion but no deviation. Condition is dispersion but no deviation. So for the crown glass, your mu V and mu R have been given, and for flint glass again mu dash V and mu dash R have been given. What was the condition? Again. Try this first on your own and solve it. So I'll give you a couple of minutes to solve this on your own first. Okay. Try this on your own. This should be easy. So you realize I just told you that the condition for dispersion without a deviation is this. This is dispersion without a deviation. Now, instead of yellow light's refractive index, you've been given the refractive indexes of violet and red. If you remember, this is how you find the refractive index of yellow. The refractive index of yellow would be the average of the refractive indexes of the red and violet. That should help you. Should help you with this question. Now, so let me just wait for one more minute so that if anybody is solving and is about to give me an answer, so I want to give you a chance first and then I'll solve. Again, as I said, as I keep saying, all the questions on thin prisms are very straightforward formula based. Nothing about them is difficult. Okay, so this should be. So from here, why don't I go ahead and solve this? So you were given information about the crown glass. So A of crown glass is 5 degrees. Okay. Now the mu for crown glass, mu violet is 0.52. The red is 1.515, if I'm not wrong. Yes. So can I say therefore mu for yellow would be equal to mu R plus mu violet by 2. So mu of yellow would be simply the 0.519. Okay, if I find the average, it will come out to be this. Similarly, for A of flint glass, I don't know. And mu for flint glass, mu dash is known to me. That is 1.688. Also, mu dash for red is known to me. That is 1.650. Okay. So therefore, mu dash y would be nothing but mu dash v plus mu dash r over 2, the average of the two. So can I say mu dash y would be equal to 1.669? Find the average, that will come out to be this. Now I know for dispersion without deviation, I know that the condition was that a into mu y minus 1 will be equal to a dash minus mu dash y minus 1. Therefore, a for Flint would be 5 into 2.519 over 0.669, and that would be your answer. Okay, so as simple as that. Now, कुछ भी नहीं है यार इस question में. Let's just quickly calculate this value. 0.519 over 0.669 to 5. So the angle is roughly 3.88. The angle of the Flint glass is roughly 3.88 degrees. If you have an angle of, if you have a Flint glass prism of angle 3.88, if you connect it with this round glass prism, then that would produce a dispersion without a deviation. All right, so last question for the day, and then we wrap up today's discussion. So again, you have to now find the angle of prism of prisms of dispersive power 0.02 and refractive index this to form an achromatic combination with a prism of 1.4.2 and dispersive power of this having refractive index this. Also calculate the resultant deviation. So whenever you are told achromatic combination, achromatic means that the dispersion should be zero. Dispersion should the deviation should not depend on the color. Chroma means color, so achromatic means independent of color. Achromatic combination means you don't want any dispersion. So there can be deviation but no dispersion. Also calculate the resultant deviation. So again, this would be simple. So if you remember the condition for no dispersion, what would that be? Now the refractive indices have been told, right? So the refractive indices will tell you the again remember this, that refractive indices are mu y's. These are the mu y's. Y and mu dash y. Just remember that. Okay. Dispersive power, you already knew, omega 1 was equal to mu violet minus mu r over mu y minus 1. Correct? So you want mu violet r would be equal to omega times y minus 1. Similarly, mu dash v minus mu dash r be equal to omega dash times mu y dash minus 1. Now I know for deviation without dispersion, you want that a times mu dash r dash equal to a times, and also you will realize, so that's very simple, that mu that you have been told is already the refractive index for yellow. So just substitute those values and that is it. Sorted. Okay. So I hope everybody followed this. Get this. All right, so this was the last and the final thing that I wanted to discuss to you about prisms. That concludes our entire discussion of prisms, and hence I think our entire discussion about ray optics. Okay, so yes, there is a matter of optical defects and optical instruments. We'll take that up after wave optics. So anyhow, this is where I would like to bring today's session to an end. And before I leave you for today's day, Let me quickly remind you that if you haven't gotten your Unacademy Plus subscriptions and if you have been planning to get one, these are the steps that you need to follow. You can go to the Plus section of the app, select your goal as IIT JEE, and click on the Get Subscription button. Okay. Now, the moment you do that, you will be redirected to the payment page where you will find a box that will say, do you have a code? So that is where you can enter this code, RD Live. Okay. And this code will give you a 10% off on all your subscription fees, whether you select the Plus subscription or the Iconic subscription. Okay. You get this 10% off across all subscriptions. Okay. The fees of these subscriptions have been mentioned here, and you realize when you click on proceed to pay, you also get the chance to break this payment into a lot of smaller no cost EMI options, so that you don't feel the burden of these payments as well. All right. So those of you who don't know what the Iconic subscription is, let me quickly tell you about that. So the Iconic subscription is something that will take your IIT JEE preparation to the next level by allotting you personal coaches. So with the Iconic subscription, you are allotted personal coaches. These personal coaches will closely monitor you and guide you throughout your IIT JEE journey. And you'll also get chance to attend IIT JEE workshops, receive expert guidelines, get study planner and regular test analysis. So with all these extra benefits apart from your plus and your personal coaches, your JEE preparation will definitely reach to the next level and you'll power through your IIT JEE journey. All right. So students who have just entered their class 11th and are worried about how to go about their studies for the next 2 years, you need not worry. Unacademy now presents you combo subscriptions, which are a single one-stop solution for all your study needs. So there are 4 combos which are available. Okay, so these combos take care of your class 11 CBSE studies, class 12 CBSE studies, your board examinations, your JEE Mains, your JEE Advanced, everything taken care of by these combos. Okay. There are 4 combos that you can choose from. The first combo offers you the plus subscription for the Iconic subscription for IIT JEE and plus for 11th and 12th. And this combo starts at 4,600 a month. The second combo offers you the Iconic for IIT JEE and Iconic for 11th and 12th CBSE. This combo starts at 5,500 a month. Finally, you have another subscription which offers you plus for IIT JEE and plus subscription for 11th and 12th. And this combo starts at 3,000 a month. And finally, you have a combo which offers you the plus subscription for IIT JEE and Iconic for 11th and 12th. And this combo starts at 3,900 a month. These combos, you can select one combo that suits your study needs and then forget about all your study worries for the next 2 years. Okay. Next, if you like today's session, then do not forget to press the like button and share it with as many people as you can so that more and more students receive the free quality education that is being provided through this channel to every student. Okay. Spread the knowledge, spread the love. If you're new to the channel, don't forget to subscribe to the channel and don't forget to hit the bell icon. Okay. Now the PDF of all the slides used in today's lecture would be available for download very soon. Next, students who are following us on this particular channel of YouTube, that is JEE English, Unacademy JEE English, do not forget to connect with us on the Telegram app using this link. Okay. That is where you will receive all the timely notifications of every lecture and session happening here on this particular channel of YouTube. So with that, let's bring this session to an end. And let me remind you one final time that you can use this code in multiple ways. One code, multiple uses. This code RD Life helps you unlock the free features of the Unacademy app. Okay, free features of Unacademy app. Then gives you 10% off on all subscription fees. And then you have finally can enroll all Unacademy events like the Unacademy Combat, etc. So this unlocks for you every event of Unacademy also. So these are the major 3 benefits of this code. So with that, let's wrap up today's session. And next we'll see what we can do. Okay, so I'll see you soon. Till then, you guys keep studying hard and keep practicing hard and take good care of yourselves. Bye-bye.